And so far we have covered about motor control, battery sections, and basic models. So now we are into powertrain modeling, day 22nd. See here we are into powertrain modeling. Yes, so powertrain modeling. So under this we are going to discuss various aspects like gearing mechanisms. Yesterday we have covered the brake mechanisms. So have you participated? Have you practiced this braking mechanisms with MATLAB Simulink? So can you please comment? Have you practiced the brake experiment? Yes. So have you practiced the brake experiment as per the previous class? Surab Modi, please don't make videos private. No. See, actually after the live, the video will be moved to the private mode. So you please rewatch the video within 3 days. Yes. Thank you, participants. Swaroop, Ratna Raju, Busha, Vashant Kumar, great, Ramadurai. Data sheet is available on the internship portal. So please watch the internship portal. Yes, great. Low, yeah, Maya, thank you, participants. So others, those who are all not practiced, so please practice this thing. Mr. Surab Modi, if you are the internship user, so you can join in the internship and you can get all the stuff. You can watch all the videos at any point of time. MATLAB Masterclass is a different channel, so it's a pantechsolutions channel. So please check with that channel, right? So that is one more team from our company. I have joined internship. How can I see day 2 videos and other videos? So please watch the internship portal. In the YouTube, it's not available. So please watch the internship portal. That is the LMS portal. Yes, very good evening, Swapnil. Yes. So others, please practice the experiment, whatever we shared in the live class. So please practice it. So now we are going to discuss about from the previous day classes, previous day examples. So now we are going to use 2 different ideal source. With that source, we are going to excite the vehicle. So actually in the previous day example, we have used free body diagram and a slope angle we have used to drive the vehicle, right? Similarly, we are going to remove the slope angle. So just we are going to keep the vehicle on the flat surface road. Now we are going to excite the vehicle with the ideal power source like angular velocity source as well as the torque source. Those components are available in the MATLAB. So which means that we can ensure that our vehicle can respond for the any movement, right? So please watch the class and keep engaged with the entire class. And after that, we are going to design a multi-speed like a gear mechanisms. Even though the electric vehicle is not required the gear mechanisms, so still you can go with the gear also, right? Now there is no any limitations whether you should go exactly without gear or with the gear. So in the EV, you have an option to go without gear also, since it's a power direct drive systems, right? And in this example, the gear system why I have included the sense you should know how to gear mechanism is working in the MATLAB. So in that aspect, I have included this one. And similarly, finally, we can once all the verifications done, then we can calculate the motor power, and that the same motor power can be connected to the vehicle body. So and after that we will excite the motor. So how much motor power is required and how we can derive those things, everything we can integrate with the DC motor, right? So is it clear? So about the today topic. So are you ready to learn the concepts? If you are ready, please comment the comment box ready. So here I have used to reduce the speed purpose, the gear mechanisms. Yes. So if you are ready, please comment the comment box ready so that we can move forward. Yes. Thank you. Great. Yeah. Yes. Okay. Okay. Great. Fine. So let's move to the next one. And see, actually, as per our previous sections, so I'm going to take a previous classes. Yes. See, actually here yesterday we decided. Yesterday we have verified this. This is the powertrain terrain data. So this has been introduced to drive the vehicle. So now we are going to just leave this one. Simply we are going to connect a 0 degree, right? So just apply 0 degree here. So which means that our vehicle is going to be in a flat surface. So now we have to add the drive system in the rear wheel or front wheel systems, right? So now we are going to include this in the front wheel drive system. So straight away we are going to connect the vehicle drive source to the wheel. So let us check how the vehicle can be working, right? So these are all the brakes. So let us apply this brake at a different level. Let us apply the brake at a different level. So initially we have applied just 20 seconds and then 25 seconds. So now let us run the vehicle for 100 seconds. So in that case, first gear we can apply at 75 seconds, and then second brake we can apply about 85 seconds or 90 seconds, right? So first variations is this brake mechanisms, and now we are going to just move the vehicle with the power source. Camera on voice is breaking. My God. Actually from here there is no any issue. Okay. Oh, everything is perfect. My voice is audible. Still is it breaking? So let us remove the image so that you won't feel about the break. Is my am I audible? Is still my voice is breaking? Is still my voice breaking? Can you please comment? I have removed my image. Okay, thank you, Hariharan. So now I just remove my image. So whenever I switch to the presentations, I will display my screen. Yeah, thank you. Yes, thank you, Rigvit Sharma. So now let us change the. Let us include the ideal angular velocity source. See here, just to take this one, ideal angular velocity source. So just to add, simply we are going to drive with the manual connections, right? So manually we are trying to just push the vehicle by this one. Take a reference, mechanical rotational reference, just to connect, and here only we are going to apply a manual input. So just to take Simulink to PS converter, and take a constant block. So via this constant block we are going to apply a value, right? See here we are going to apply the radian per second value. So this is since it's an angular velocity source, so straight away this value whatever you are applying, so the same value that is that equivalent RPM should reach. It's not RPM, it's a radian per second. So in that case we can measure the kilometer per hour, right? So this is the kilometer per hour value. So now let us check, just run this simulation. So since we have applied one value, so let's check how this is responding. Yeah, see here that is a 0.2522. yeah, so the vehicle has started. So now just to increase the value, so about 750 radian per second. So let us take 750 radian per second. So I choose this just as a random value. So you can keep whatever you want. Just we are going to verify whether our vehicle is going to run or not. Yeah. See here so the vehicle has started to run. So this vehicle is rotating at 30 radian per second, 30 kilometer per hour, and at the 90th instant we have applied one brake, 75 and then 90. Yes. So still if the kilonewton is not enough, so just try to increase this value so that you can see the brake whether the perfectly it's applied or not, right? Yes. So still it needs more braking mechanisms. So like that we can include another one. So this is the ideal angular source. Similarly we have an ideal torque source also. So actually the both are different. See here the torque as well as that ideal angular velocity, which means that yes, just a second, I will give you the information. So earlier we have used ideal angular velocity, now we are going to use ideal torque source. See actually the ideal angular velocity will give you will generate a differential velocity. That is, it generates a velocity difference at its terminal. See the motor terminal, it will give you the different velocity. Similarly, the ideal torque source, actually in the MATLAB, in the MATLAB, we are going to see the difference one, right? See here, this is the angular velocity. Similarly, we can take ideal torque source. So just to take ideal torque source. Yeah. See here, if you measure the torque value, whatever we applied here, so the torque value for this reference speed, the torque has been generated. Suppose if you use this, then whatever the torque is constant, whatever we are applying the torque value, so that is a required value. By default, suppose if you are applying a motor, so in the motor we cannot feed the direct value torque. Right, so we know the voltage of the motor. If we change the voltage, then we can adjust the speed of the motor. So indirectly, if you know the motor power, then we can calculate how much torque can be delivered by the motor. Right, so now we can estimate how much torque we need to rotate at the same speed. So just to remove this one, yes, just to remove this. Okay, my system is little bit slow. Still voice breaking is experience. So try to manage this one. Yeah. So now we are going to use the torque source. So before that, we can measure the torque sensor. So just to take ideal torque sensor. Yes. Just to connect as per this one and take PS to Simulink converter. So this is the torque value. So which it is generated by the system, right? So now this much amount of torque is required to run this vehicle at a desired speed. See here, this is the torque value which is developed by the system. And even though actually see here at the 75th instant we have applied the brake, right, to stop the motor. So in that case the torque again it has increased. Similarly this also actually at 90th instant also we have applied to increase the to apply the brake. So during that system also the torque has been increased. That is the changes of the torque. Similarly, if you change the value, right? See, instead of ideal velocity source, just to use the ideal torque source, just to rotate it. So if you apply 40 Newton meter, 40 or 50 or whatever you want, you can take it. So now let us check how this motor vehicle is responding. Yeah, so we achieve the same speed and the torque. Now this will be a yes. So this is the ideal torque source. So whatever we apply, the same torque has been applied. So now let us check this one. See here, due to the constant torque, earlier the torque is not a constant, it's a variable one. So now we have applied the constant torque requirement. So due to this, see here, before that one, the source has been varied. So now the point is, from this experiment, you can understand how much torque is required to drive your vehicle on perfect manner. So in that case, you should know the motor power rating and the torque rating, right? So is it clear? So and again, see actually since this experiment, these blocks are looks like a complex components. So I'm going to consider this as a subsystem. So let us take all these things in the subsystem. So just to create Control G. So this is called a subsystem. And similarly, this is the braking mechanisms, right? So this is the braking mechanisms. So let us consider this is the braking mechanisms. So this is the brake system. And similarly, this is the vehicle model. So this is the vehicle model. Vehicle model. And this is the output of the vehicle. Thank you, participants. Just use Control G to create a subsystem. So now you can change the parameters of this one also. So see here, you can use these comments to change the. You can use to comment. See here. So no need to see the content preview. So in that case, you can you can uncheck it. Then the block will be there, and you can use any other images also. So in that case, you can use the mask system to change that one. and here you can create a mask and all. So you can add icon image. So whatever you can use that image, you can use it. So like that you can check, you can create whatever you have actually. Yes. So like that you can add your own image. Right. So now we are going to introduce the gear mechanisms, right? So for that one, see, this is the two different level of speed. Similarly, we are going to use three different speed mechanisms. So for the three different speed mechanisms, I have already developed this project. Yes, yes. See here the three level of speed. So first we have to develop this mechanisms like a three different level. If you apply a 1 Newton, one radian per second speed, so that speed should be divided by 3. So this is a half of 1/3, and then first one equal speed, and then 2 by 3. So like this, 3 by 2. So this is 2 by 3, and then this is 3 equal to 3, and then 1. And then this is a 3 by 2. So like that we have to change the speed. So for that one, so first we should know how to differentiate this signal. See here the how to differentiate the signal in the sense. So just to take I'm going to create a new block. Just use new model. If you feel this video is lagging, so please adjust. Actually now in between I cannot do anything. So try to manage these things. So I'm going to take first a signal builder. So I'm going to take just a signal builder. So now up to 30 seconds, we are going to divide this three different levels. So in that case, just use change time range. So we are going to implement a 3 gear system. First gear for 10 seconds, second gear for 10 to 20 seconds, and third gear for from 20 seconds to next 30 seconds. So I'm going to extend this signal from 30 different signals. So adjust this one. So just extract at 20 and 10, 0 to 10. Adjust this value like this. 10 and 20. Similarly, just to change the Y display limits from -1 to Y values, right? So this is 1, and so this is 4. So which means that 3 signals we are going to get it. So just change to 3, yes, and change to 3, and similarly adjust this. So now which means that till 0 to 10 seconds first gear will enable. From 10 to 20, second gear will enable. From 20 to 30, third gear will enable. So now we have to separate this 3 signals into individual seconds. So in that case, so now let us check the output. Take a scope block, whether are we getting the proper signal or not, right? So just run this signal, run this simulation for 100 seconds. Just run this for 100 seconds. Slightly there is a difference, so we have to adjust the value still 20, yes, and now we have to slightly adjust this one. See here 3, and similarly here also we have to apply 3. So now just run this one, we can get a proper output. Yes, see here 10 seconds first gear, 10 to 20 seconds second gear, and after that the third gear. So like that we will apply a vehicle. Whatever you are generating the speed, the same speed will be modified as per this one. So now let us take an angular velocity source, ideal angular velocity source. Just to take this one and take a constant. Just to take a constant one and take a Simulink to PS converter. Just to take a Simulink to PS converter. So which means that so this is the 1 radian per second. This is going to apply with different gear levels, right? So just to take a mechanical rotational reference, yes. So now we can take a clutch, right? So that clutch we have to modify, use it. So just to take clutch, CLUTCH, disc friction clutch. See here, so there are the 3 different pins. So which means that whatever you are applying the speed, whatever you are applying the speed, this speed will be transferred whenever the pressure signal is high, right? So this port, the P port, whenever the P port P exceeds the engagement threshold pressure, right? The signal port, physical signal port, P exceeds the engagement threshold pressure. So in that case, the same speed whatever available at the B, so this will be transferred at the, this will be transferred to the what? So output port, right? So from here we can add the gear mechanisms. So from here we can add the gear mechanism. So just to take a gearbox, just to take a gearbox, just a second, it will take some time. I think I have choose the missing, faulty component. Yes. So just to take a simple gearbox, just to take a simple gear and apply here. So which means that first gear is the very low speed. So this will be 3/2, right? So this is the very lowest speed. And after that, here we have to apply a same speed. So without a gear, we can take it. So this is the another one, right? And after that, just separate the speed. So this is the high speed, right? So here we have to take, here we have to apply 2/3, right? So the 2/3 value is very low. So that is the low one. So this is 3/2. This is 3/2. And this is 2/3, and connect accordingly. So here we have to generate a control signal. So this P signal we have to apply whenever the pressure is high. So greater than the threshold value. So this clutch will get enabled, right? So from this from this gearbox. So from this 3 different control signal, we have to derive this one. So let us take, this is a low, and this is a medium, this is medium, and this is high. Okay. So now we have to develop a logic to separate where it is one, how long this signal is 1, and how long the signal is 2, how long the signal is 3, right? So for that one, just to take a compare signal. So the compare signal is, so since it's a constant value, you can take a compare signal. So just to take a compare, there will be a, compare to 0, compare to constant. So just to take a compare to constant. So first, if you take a equal to, yes. So if it is equal to 1, then this will enable high, right? So this will enable high. Similarly, if it is a 2, if it is a 2, then during this period only, this will give you a high value. So see here. So this is the low. If the signal comes here, then this block will be enabled. This block will be enabled during this period only alone, and this block will enabled during the second gear block. Similarly, we have to generate a third gear. Just to change it to third. So this is simple logic. So actually, as per my requirement, I have developed. So whatever you want, you can choose whatever there. And let us connect this one, right? So here, and again we have to apply a physical signal. So in that physical signal, generally we have to apply via the constant one. Okay. So let us take a switch case. Let us take a switch case. Yes. So by default, during this period, this block will enable high. So which means that above 0, right? So in that case, we have to apply a high value. So let us take a pressure. Just we are going to ensure the pressure. So like you just imagine how much pressure you are going to apply in your real-time vehicle. So in the clutch pedal. Right, so just to take a constant block. So here just apply 1000 value. So I'm going to keep it maximum value. Similarly, this is the minimum value. So here rest of the period will be 0. Right. So if it is 0, then this clutch will not work. So in that case, the pressure will not, the speed will not transfer to the gear mechanisms. Yes, is it clear? So can you, if you have any questions, you please comment. Is it clear? If you have any questions, you please comment so that I can answer your questions. Just I'm rearranging this one. So just to create this is as a simple subsystem. So now we have to connect this one. So since it's a Simulink signal, then this is the Simscape signal. So we have to take Simulink to Simscape converter, right? So just create as a subsystem this 3 model. Just to create subsystem. Yes, right. So now you can connect here. Similarly, just to take the same logic. So just to connect accordingly. Just take, right? If you have any questions, you please comment here. So now this is the H port. So we are going to measure at here. So just to add the inertia block to fix the here. Yes. Similarly, we are going to take a sensor, that is ideal rotational motion sensor. Just to take. So the rotational motion sensor will help you to sense the angular velocity. Ideal rotational motion sensor, right? Just to connect. The basic systems needs to be there. So just to connect. So simple ideal source we are going to connect it here. And so reference we have to take it. So just mechanical rotational reference. See, just to take this as a reference signal. And in between damper we have to apply. So it's a open-ended system. So we have to apply a damper. So just to take a rotational damper. So from here we can measure the velocity of the speed. So just to take a Simulink PS2 Simulink converter. PS2 Simulink converter. And take a scope. Similarly, this is the after the gear, right? So before the gear also we should know. Then only we can compare the speed whether our gear system is properly running or not. And take a reference. So just to take a scope block. Just to take a scope block. And this is the before the gear and after the gear. And then gear input. So this gear input we have to take, right? So just add the PS solver configuration. Just add the solver configuration. Yes, all right. So now let us try to run this one. So this is very simple gear mechanisms. So we are going to test. So once if this block is completely running, then we can take as a we can create as a subsystem, and then we can directly connect to the main system. Just to change this one, these signals. Yes. So now I have missed some value. Yes. So here the 3 speed should be there. So input speed. This is the output speed. So the speed rotation has been changed. PF 3/2. Okay, right. So here the same direction as per the input. So just to change it, same directions. Yeah. Here the 3 different speed is there. So just to change the value to 2/3, 3/2, and yes. So you can program whatever you want based on this one. So simply based on this control signal, the gear has been changed. Yeah. See, this is the input speed and this is the output controlled speed. Right. So like that you have to develop your gear mechanism. So once if you know the gear mechanisms, then we can add the same gear mechanism and then we can get a different speed, right? So and after that I have included these things, and so now we are going to add this one with a different ideal speed. See here I already have modeled, so the same logic I have modeled. So this is the general vehicle model as well as that brake model, and then this is the gear mechanism. So here the inside, so the same logic whatever I have developed, so the same logic I have used. So now if you run this one, you can get 3 different speeds. So this is the gear 1, then gear 2, and then gear 3. So this 3 different speed with a different braking mechanism. So at see here, the first gear. First brake has been applied at 50th instant, 50th seconds instant, and 75th second instant. Right, so the 2 braking mechanism. So now we have developed the ideal drive mechanism. So now we have to replace this source. So we have to replace this source with the DC motor. So as we know how to model the DC motor with the Simscape, right? So as you know, how to model this DC motor with the Simscape. See here, I took this is another example. Yeah. So the same experiment with a different input. So I have removed all the ideal sources. So this is the actual source which we are going to use it. As per the calculations, see the motor weight is about 370 kilogram, 317 kilogram, and 1 to 1.5 meter area, that is the width and the height. Similarly, rolling resistance, whatever we developed. So the power rating is about 1.5 kilowatt. So in that case, we can take a DC motor as a 2 kilowatt. In that mode, we can take a DC motor power rating is of 2 kilowatt. And then RPM is, that is that no load RPM is 750 RPM, and then rated speed is that is the fully loaded. So in that case, 500 RPM. Right. So now we are extracting the physical signal. So here we are applying a electrical signal, and with the help of this motor we are generating the mechanical signal. So this mechanical signal A is transferred via the A and converted to the hub, vehicle hub. See here, then this power is connected with the rear axle. So this power is connected with the rear axle. Right, so this rear axle. So whatever you want, you can connect, either front or rear. You can connect. So if you connect it to the rear one, then this is the rear rear wheel drive. If you connect to the front one, then this is the front wheel guided vehicle. Right. So all the things are been constant. So if you apply the motor, see here we have applied 100 voltage DC voltage, constant DC voltage source, and then DC motor just simply applied, and we can get a variable speed. So whatever we took from the ideal source, the same kind of performance we can take it from here, right? So 3 different speed, and now the point is you have to introduce the power electronic circuit. As per our previous learning experience, we have to include the power electronic circuit to control the motor, right? So this is the raw just control DC motor connected via the gear system to the vehicle. Is it clear? So can you please comment? Is it clear? So can you please comment? What is the use of damper? See, actually that is the open source physical system. So in that case, damper nothing but, see, simply you cannot hold the motor in your raw hand. So you have to mount the motor on the perfect bed. So similar kind of mechanism is available on the mechanical things. So for that only we are using the damper as well as the inertia. So now can you able to add a power electronics controller circuit like a 4-quadrant chopper to the motor to vary the motor speed. Thank you participants.